We're talking about arcs and chords. You're on page 213. And I realize this is not in your notebooks, but I want to show you the difference between an arc and a chord. Okay, right here, off of this, what is it called? It's in the funny papers? Comic. Oh my goodness. So off of this comic, you've got a chord. So from this circle, a chord stops on the circle, right? Do you agree that's a chord? Okay, an arc is off of the chord. Are you ready? So that's the chord. An arc would be this. It's a piece of the actual circle. Yep? How many of you? Okay, you got it. Arcs and chords, that's what we're talking about today. We have lots of vocab to go through. So let's, page 230. Angle. It's right there. Once you say it out loud, that literally is what it is. So if we're talking circles, what do we need to do first with the circle? Yeah, find the center. So central. So draw yourself a circle. I'm going to be nice to myself and put circles up here. You don't have to watch me attempt to make a circle. So find the center. Just eyeball it. Central. Angle. Now off of the center, you have to make an angle. So maybe like this. What do you think? Does that look like an angle off of the center? It's a central angle. It has to come off the center of a circle. Okay, now I'm also going to teach you something else right here. Okay, if this angle measurement is, what does that look like? Maybe 80 degrees? That's the central angle, yeah? Well, off of the angle is an arc. Right there, that orange piece is an arc. If the angle is 80 degrees, any guesses what that arc measures? Okay, you got it. It's also 80. It's like the easiest concept ever. If it's off of the center, then the arc angle is the same measurement, 80 degrees. That'll come up later. Might as well show you right now.
Wait,
80 degrees. Because if you measure an entire circle all the way around, what's degrees? 360, yeah. Okay, minor arc. Now literally it's a piece of a circle, but minor arcs are little guys. They have to be less than 180 degrees. Question. This comes up almost every time my little guys, my little seventh graders take a quiz. They'll say something like, but is 180 less than 180? What do you think? Do you count 180 in there? No. Would you count 179.9999999? Yeah. So just remember, don't use 180, use everything smaller than it. Draw yourself a picture. Let's make ourselves a minor arc. Okay, if we let's put letters on the side, just points. So maybe that's point A, B, and C. Okay, less than 180, like we were just talking with Allie. The whole circle is 360 degrees. So if we're going to get a piece of the circle that is less than 180, would you say that this, I'm trying to choose a color that'll show up, this arc, do you think that would be mine?
Yeah.
Sure. Arc. Can I show you how to write arc? If you want to name that arc, you put a little loop-de-loo. That's arc AC. Arc AC would be a minor arc. It's less than 180 degrees. Okay, if a minor arc is less than 180, major arc, what do you think a major arc is? Okay, definitely greater than 180, but I'd say you gotta cap it. There's gotta be a cap on that circle. It can't be more than 360. How come? Yeah, we've got our circles 360. So major arc, I would say bigger than 180. It's gotta be bigger, but less than what, guys? But it's gotta be less than 360. Okay, sketch yourself a circle. All right, sketch yourself a circle. Describe a major arc. How are we going to do this one? Any ideas how to do this one? What do you think, Tyler? Arc A, B, C. All right, I'm going to write that first. So arc is a little loop-de-loo. I like that you use 3 letters because when naming an arc, it's like a map. It's saying start at A, then go to B, then go to C. So right here, start at A, go to B, Go to C and stop. What do you think? Is that a major arc? Let's say it barely passes. It's barely bigger than 180. Minor arc, major arc. How many of you? I got this concept. You good with those? Minor, I think it's little. Major, it's big. Semicircle. This is the other one. We've got smaller than 180. We have bigger than 180, but we don't have straight up 180. That would be okay. Equals 180. If the arc equals 180 and arcs are off of chords, something's going to have to happen with this chord in order for the arc to be 180. Yeah. What do you think, Ted? Yes, and that's exactly what Garrison just said. The chord is going to have to be the diameter. So eyeball it. Good luck drawing in the diameter. So that arc, semicircle, would have to be from here to here off of the diameter. Okay, measure of a minor arc, measure of a major arc. We already went over this. Let's just do practice really quick. If I can make one up on the minor arc. If I have my central angle and I give you that this is 60 degrees. Can you tell it's 60 degrees? What's the measure of that minor arc? Yeah, you picked that up real fast. So measure minor arc 60 degrees. Remember, it just has to be less than 180. Major arc, same thing. Let's just do a circle. Okay, major arc. What if I do the same thing? I'm going to make this one a little bit smaller. What if I tell you this is 60? Is that a major arc? Is there a major arc in that picture though? Can you tell me the measure of the major arc?
300.
Wait, what is it?
300.
Okay, you started with 120, and then you went to 300. Are you sure?
Yeah.
Okay, so this part would be the major arc. So this whole part would have to be 300. How come? Oh wait, Christian, how come? Why do you think that would have to be 300? Exactly. Altogether, it's got to be 360. So if you're focused on the major arc, that major arc would be 300 degrees. Okay, last vocab. Oh my gosh, this comes up all the time. Congruent something, congruent something. What does congruent mean? The same. So it's just an arc that has the exact same measurement as another arc. So congruent arcs have the same measurement. Technically same shape too. Okay, but with your thumbs, how are you feeling about this vocab? Thumbs up, I got them. Halvesies, I got most of them. Down, I was just copying the whole time. Let me see, how do you feel about these? Alright. Some wishy-washy, mostly confident. Okay. They come up later, let's keep practicing with them. First one's, oh, I feel like this is a giveaway. However, it's really good practice for this. Because what does this little loop-de-loop mean? What does this M in front of it mean? So the measure of arc ABC, this is a guideline, it's a map. Start at A, go to B, pass up B, end at C. First question, major or minor arc? Totally major, right? So that's a major arc. Well, what it's saying is you can break this into pieces if you don't know the whole thing all at once. It's saying you can take arc AB and add it to arc BC. Do you feel like that's pretty logical? They're saying if you don't know the whole thing at once, add the two pieces together. So you can take arc AB and add it to arc BC. You'll get the whole thing. Arc addition, postulate. You're just adding it together. Okay, flip the page. Will you please try those 3 examples on your own? Look at the picture. Good luck. Try. If you look at DG, is there any way to go from D to G without passing another point? There's a point in between, right? So some of them are like, well, which way do we go? How do I know? If it just has 2 letters in the measure of the arc, the name of it, go the shortest route. It means the shortest route. So you just gotta look at it. Shortest route from D to G looks like it's from to here. How many of you did that without even really thinking about it? You did? Okay, add it together, what do you get? 150. Okay, so DG is 150. Okay, next one, it's more specific. So D, then G, then H. So D, then G, NH. Blah. First question, major or minor arc?
Major.
What is it? Add it together. 270 for a major arc. You know what? Let's add that in our notes. It's good practice. Add that in. Same with number 1, major or minor arc?
Minor.
Ooh, yeah, minor. Because it's less than 180. Okay, VH, good old VH right here. With nothing off of the central angle. So on a hand in there, how did you figure out this one then? I'm sure you figured out, but how did you do it? Go ahead, Allie, what'd you do?
So I used 270 since that's all the angles except for DH.
Uh-huh.
I did 360 minus 270 and I got 90.
Nice. 90. Okay, 90. Major or minor arc? Minor. Add it in 2 notes. It's good practice. There's one super friendly part of your assignment. Let's just, what is it? Major, minor, or semicircle? Okay, feeling good about those ones? You okay? Roadmap or shortest route? Are you ready? Okay, so what this one is saying is, if this piece right here, if this chord BC equals this chord AB, something is going to happen with arc AB and arc BC. Any guesses what? They have to be the same. They have to be congruent. So it's saying arc AB is congruent to arc BC only if you already knew that these two are equal. So if you knew that that segment, that chord AB was congruent to BC. Okay, the next one, perpendicular stuff. So this one is saying if the diameter, so diameter has to go through what part of the circle? Okay, it has to go through the center, so they're talking about this right here. If the diameter is perpendicular to a chord, so there's a chord right there, then this is going to bisect. Oh, wait, first, what does bi mean? What does sect mean? Cuts into 2 equal pieces, so bisects it, cut, cut. Okay, well, if those 2 are equal, what do you think about this arc right here and this arc right there? Those are also equal. So much going on in that picture, right? So if DE equals EF, then arc DG is going to have to equal arc GF. Go ahead, Ellie.
Wouldn't D and then halfway and then F halfway equal to?
Yeah, totally. Perfect, perfect, perfect. Okay, I think the next part of your theorem is this same one, 10-5, only backwards. Let's look at it. So it's the converse. Yeah, it's saying if you know that this is perpendicular to something, if you know that these 2 pieces are congruent, then what do we know? What does this JK have to be? It has to be the diameter. So it's that same thing, only backwards. It's more focused on the diameter. So chord JK, segment JK has to be the diameter. Okay, really quick, I'm going to sneak it in just for practice. What do we know about LK and MK? Okay, they're equal. Good job, good job. Okay, last one. This one I always kind of have to wrap my head around it, but I like that it says it in words. So right here it says, in the same circle, or congruent circles, 2 chords are congruent. So chords, they're talking about this piece, this chord CD, this chord AB. Okay, those 2, you can say they're equal to each other, but only if you know that this is congruent to this. If from center perpendicular and from center perpendicular is congruent, then those chords are congruent. Oh my gosh, so much over that. Okay, so you would have to know that that little guy EG is congruent to EF. Okay. There's actually another thing coming off of this. Right here in this picture, what do you think about arc CD and arc AB? They're also equal. Do you have a question about your stretcher?
So how is it possible? Can it be angled differently?
Oh, that's a good question. He said, can it just be angled differently? How does that end up working? The angle's going to be fixed if it's 90 degrees.
Also,
Has to be 90 degrees. That's a great question. Okay, keep that one in mind. Now, this entire page with the theorems is really helpful for the bottom half of your assignment. Because the bottom half of your assignment, it says, what do you know about these pictures? Use these theorems to say, well, this would have to equal this would have to equal this. You might want to keep your notes out today. I know you don't love doing that, but I highly, highly suggest it. Okay, first one, right here. This is what tricks people in this chapter. Directions. Are we looking for a variable or are we looking for an arc? We're looking for the arc, but we've got to find the variable first. So right here, guys, in the picture, what do we know about arc KM and arc MN? They're congruent, that's one of the theorems, right? Okay, I don't love how they solve this. I mean, if you want to fill in those blanks, go for it. I'm going to write my own. So they're equal, so I'm going to put 5x equals 7x minus 16. Okay, I'm curious now. Looking there, I know what they did, but what would you guys do? What would you subtract first from both sides? I heard 7x, and I agree with that. Don't worry about the 16, because can you combine it with anything over here? No, but if you want to make it positive, I get where you're going. So subtract 7x. 5x minus 7x, what happens? Is that okay?
Yeah.
All right, that's okay. We've got negative 2x. This is why it's okay. Because is this a positive 16 or a negative 16? It's a negative 16, so those negatives will come out. Because divide by a negative 2. Guys, what's the negative divided by a negative? Positive. So we get positive what? Again, this is what people get tricked on in this section. They circle x equals 8 and they move on. But if you go back to the directions, did they ask for x? They want which arc? KM. So go back to KM. Oh, in the picture it's what? 5x. So take out the x, put in the 8. What's 5 times 8? There we go. So this arc right here is 40 degrees. That's our final answer. Feel okay about that one? Okay, do number 1 first, because it's exactly what we did. Just barely. Will you try this one on your own, please? Okay, wrap it up. First question, listen closely. What did you get for x? Just x? 6. How many of you set it up like this? Yeah, we good. Subtract 3x, you'll get 24 equals 4x. Make sure I do this right. Divide by 4. I agree. X equals 6. Ah, that's dangerous that I boxed it, right? Because if you go back to your directions, what is it looking for? It's looking for the arc, right? RS. Oh, that's convenient. Right here, it's 7x. What's 7 times 6? 42. How many of you noticed that in the directions? 42. Okay, go back in your notes. So go up a little bit. Let's do this problem. Stay with me and ask questions if I lose you. Okay, this was one of those theorems we talked about that Moot had the question about. So let's take this information and put it in our picture. So Mn is 16. This whole chord is 16. Okay, RT is 16, so this whole thing is 16. Okay, so far, I highly suggest you write down your pictures. Okay, what next? NQ is 10. Oh, okay, so right there, 10. Okay, what's it asking for? Find what? Okay, here's QS. From the theorem we talked about a few minutes ago, does anybody know what other piece in that circle equals QS? They'll be the same. Okay, let me go ahead. PQ. Okay, I'm going to put that in orange also. So these two should be equal. You okay with that logic? There's a right triangle in there. Right triangles we can use Pythagorean theorem. Calvin, what are you thinking?
NP would be 8. So
Yes.
8 times 8 plus b squared equals 10 squared.
Yes. Calvin totally got it. Okay, Calvin said this piece is going to be 8. How come, Calvin?
Mn is 16 and half of that is 8.
Yes. Good work, good work. And then he's talking about, what color have I not used? Not highlighted purple. He said use Pythagorean theorem, and he set it up using this purple triangle, and that is x. It's the hypotenuse in that purple triangle. Okay, 10. So let's set it up. So he said x squared plus, he said 8 times 8 is going to equal 10 squared. This one actually comes out real nice. Will you take the time to solve it, please? Okay, what'd you get for x? 6. So that little piece is 6. If this is 6, what's this QS? QS equals 6. Back to the directions that asked for QS. Or, oh, I put K equals 6. Better? How many of you? Okay, I get that. That one okay? Okay, will you try this one, number 2 on your own then. Feel free to write in that picture so you know what's what. Try it, try it. Convenient. Okay, so draw on your picture. DG 24, JL 24, DH 13. Oh, so they give you the hypotenuse. So we're looking for this or this, same thing. So x squared plus, okay, I almost used 24 squared. Do we use 24? Use 12. And I saw myself because I was like, how can that be bigger than the hypotenuse? So this piece has to be 12 equals 13 squared. Oh, this is what I have memorized, the something, something, something triangle. What did it come out to be? 5. I just think 5, 12, 13 triangle. So when you solve for x, you'll get 5. That's all we need, isn't it? HK will be 5. I'm curious, how many of you got that? Are you okay on those ones?